Alright, hello everyone and welcome to this video. In this video I will be showing you how to train a custom YOLOv4 object detector in Linux on your local machine. So I'll be showing you the process for both YOLOv4 and YOLOv4-tiny. Again, just like Colab and Windows, these both are the same with a very few changes. But I have made separate articles for these, so you don't have any issues training either of these detectors. So okay, let's get started. So head over to this link. I'll be giving both these links in the description. Open this link for train a custom YOLOv4 object detector on Linux, and I have Ubuntu 18.04. So okay, let's begin. Again, these are the steps that we will be following. I have devised 10 steps for this. Okay, moving on to step 1, create YOLOv4 and training folders. Create another folder named training inside the YOLOv4 folder. This is where we will save our weights during the training process. So okay, step 1 is done. Step 2, open a terminal and navigate to the YOLOv4 folder. Okay, you have to navigate to this folder. You can open a terminal and navigate to it, or just simply click on this and open in terminal. Okay, next, moving on to the third step, create and copy the Darknet executable file we have created. I've made a separate video for this on how to create your Darknet executable file for both Windows and Linux. So right now we are doing this for Linux, so you can head over to this article and also watch the video I have made on this. As I said, I've made a separate video for this. So head over to section C, installing on Linux, and just follow this process. It's fairly simple. So once you're done with this process, you'll get a Darknet folder that you have to copy. I have this folder already in my home folder, as I created this in my previous video. Okay, so now I have that folder in my home directory over here. I'll simply copy this to the YOLOv4 folder. As it says over here, copy the Darknet folder to the YOLOv4 folder on our desktop. Okay, so that's done. This has the Darknet executable file that we will use to train and test our object detector. So okay, we also have these default files in this CFG folder, in the data folder. Again, I've also shown the basic command usage for YOLO in my previous video, where I've shown how to install and create the Darknet executable in this article. If you're getting started, just go ahead and check out this article. This will definitely give you a good start on how to install and use YOLO. So for YOLO usage on Linux, I've covered a few basic commands over here. So okay, now we can move on to the next step, step 4. Create and copy the following files which you need for training a custom detector, as we have done in all our previous videos for Windows and for Google Colab, that is cloud training. So similarly, these are the 4 main files that we require. The first one obviously is our labeled custom dataset, our images, the images dataset that we need to train and its corresponding labeled files in the YOLO format. Second, our custom CFG file, obj.data and obj.names files, and finally the process.py script file, which we will use to create train and test text files. I will explain what these do in later on. I have also uploaded my files on GitHub. I'm using two classes, with mask and without mask. You can download this, and inside YOLOv4 folder you will find these 4 files. Okay, so I've also given a basic overview of how to label your image. Okay, you can read about labeling images in this article. This will give you a very good detailed explanation of how to label images and videos using various labeling tools. Okay, so I've covered a lot in this article. I've also made a few videos on this. You will find those videos down below over here at the bottom. Okay, now coming back to this, you already have your dataset with you. Let's move on to the next step, that is step 4a. Create and copy the labeled custom dataset obj folder to the YOLOv4 directory. Now you have to put all your image files and their corresponding YOLO format labeled text files in a folder named obj and copy it to the YOLOv4 folder on our desktop. So I have this over here. I've also downloaded those 4 files from my GitHub that I just showed you a while ago over here. So this is the obj folder, the dataset folder containing the images and its corresponding YOLO labeled files. This is the class and these are the coordinates of the bounding box. Okay, you can read about this in the labeling article that I mentioned. So moving on, just copy this to the YOLOv4 folder. Next, 4b, create your custom config file and copy it to the YOLOv4 folder. Okay, what you have to do is download the YOLOv4 custom.cfg file from the Darknet CFG directory, so which I mentioned earlier. In the Darknet folder we'll have these basic default Darknet files over here. Okay, you will find a YOLOv4 custom CFG file over here, so you can copy this over to the YOLOv4 folder and make changes in this over here. So these are the changes that we need to make. First is change line batch to 64, change line subdivisions to 32 or 64. Now this will depend upon the capability of your GPU. If you have a decent GPU, you can obviously give a higher batch and lower subdivisions. If you have a good GPU, you can set subdivisions around 16 or 8. That will obviously load more images per iteration, so your training will be much faster. However, if you don't have a very good GPU like mine, I have a very old GPU, I'll be setting subdivisions to 32 or 64, so that will load less images per iteration, and so the training process will be slower. Now you have to know what these subdivisions mean. So I have given a small note over here. Quickly go through this so you'll get an idea of what subdivisions are. So okay, moving on to the next. Set network size width height to 416. Okay, change line max patches to classes into 2000. Minimum should be 6000. I have 2 classes, so I have set this to 6000, and line steps to 80% and 90%, that is 4800 and 5400. Okay, that's done. And again, for YOLOv4 you have to change filters and line classes 80 in each of the 3 YOLO layers, and filters to classes plus 5 into 3, that is 2 plus 5 into 3, 21 for me, since I have 2 classes in each of the 3 convolutional before each YOLO layer. Over here, as you can see, classes and filters. Let me quickly show you. You will find 3 YOLO layers in YOLOv4. Change this, go above, change this, and again to the 3rd YOLO layer, change this, and that's it. These are the basic changes that we need to make. And this maximum batches, batch subdivision, width and height. Now I already have made these changes in the files that I've downloaded from my GitHub, which I mentioned earlier. So I'll simply copy this. As you can see, I've already made these changes in this file. You can simply just download these files from my GitHub if you're just training this for the same dataset I'm using with the same number of classes. So just copy it to the YOLOv4 folder. You can delete this. I just gave you a basic understanding of from where you can download these CFG files. Okay, so now moving on to the next step, create your obj.data and obj.names files. This is how they should look like. Number of classes, path to train.txt file, path to test.txt file. This will be path to obj.names files, and finally backup. This is where we will save our weights during the training process, which we created in the first step. We created this folder inside the YOLOv4 folder. Over here, inside this we will be saving the weights. So that is what backup is. And finally obj.names, which we gave over here. This contains the name of the classes. This is a text file. Okay, moving on to the next step, copy the process.py script file to your YOLOv4 folder. So this script is used to create the train and test text files that I was talking about earlier, where train.txt has paths to 90% of the images and test.txt has paths to 10% of the images. So okay, just copy all these. I've already done that, and copy it in the YOLOv4 folder. As I said, if you're using all the same files and the same dataset that I'm using, you can simply copy these files from my GitHub. But just to give you an understanding of what each of these do. Okay, finally moving on to the next step, copy all the files from the YOLOv4 directory to the YOLOv4 Darknet directory in their respective folders. Now what we have over here is a backup of all these files. We will be copying this inside some of these folders over here. So in case anything goes wrong, you can come back, and again you have your original files over here. So now what we have to do, you can copy all this manually through File Explorer if you like, or if you're a terminal geek, you can use these commands until 5D. So these are the same as doing this through File Explorer. Okay, I'll just quickly use the File Explorer and show you what we have to do. Copy this. First go inside Darknet and clean both these CFG and data folders. It's okay. This is just to clean it. Okay, now next I have cleaned the files. Just make sure you don't delete this file, this labels folder, as this is used to create the texts on the detection boxes. Okay, so don't delete that. Okay, next step, you have to copy all these files. Copy the CFG file, obj.names, obj.data, the obj folder, which is the image dataset, to the data directory. CFG file to the CFG directory and process.py script file to the darknet root directory. So you have to copy this to this folder, copy these two to the data folder, and copy this to the darknet root directory over here itself in the darknet directory. Now okay, and also copy this images dataset, copy it to the data folder over here, and that is it. We are done with step 5. Now we've copied all these files. You don't have to run these commands again, we've already done this. This is just if in case you want to use the terminal, as some people really like using the terminal to carry out all the steps. Okay, moving on to step number 6. Run the process.py script file to create both the text files inside the data folder. Now the current working directory is YOLOv4 Darknet, so change directory to Darknet and run python process.py script file ls data to see if both the files have been created. Just head over to the data folder just to confirm if everything is okay. As you can see, everything is fine. Okay, so the last line is 151. Since I have 1510 images, that is the 10% of this 151. So okay, the test.txt files look fine. Go over to the train.txt file. Okay, 1359, that is 90% of that. This also looks fine. You have to check this just to make sure there were no errors, as sometimes if you don't have JPG format, if you have PNG format or JPEG format, you will see a few files missing over here, so you don't want that. I've also mentioned that in my article in multiple places that you have to use JPG images, since this process.py script file we copied earlier only has this JPG format over here. If you're using any other format, you can make this change over here in this script file accordingly. Okay, now that's done. We have created these two text files. Moving on to the next step, download and copy the pre-trained YOLOv4 weights to the YOLOv4 Darknet directory. Again, you can simply download this from here and copy it to this Darknet folder over here, or simply just, again, if you are using terminal, just run this command inside the Darknet directory. We are already inside the Darknet directory. Now run this command. This will download this pre-trained weights file. Okay, we are seeing it over here. We have this YOLOv4.conv.137 weights file. Now this will take some time. Okay, good, that's done. Moving on to the next step, the training process. Now to train your custom detector, again make sure your current working directory is this. Now for best results, you should stop the training when the average loss is less than 0.05 if possible, or at least train it till the loss reaches below 0.3. If you don't see any significant change for a while, you can also stop then, but obviously it is better to get the least average loss possible. Now okay, this is the command that we use to train, as we've done before in my Google Colab and Windows tutorial. The usage is very simple. The Darknet executable file that we have, we are just running this. Detector train is the command. This is the part to your obj.data file, to your custom CFG file, to the pre-trained weights file we downloaded in the previous step. And this is don't show. You can remove this don't show parameter if you want to see the progress chart during the training process. So if you want, you can remove this, This MAP parameter gives us the mean average precision. The higher the MAP, the better it is for object detection. So okay, now just copy this command, and we have done everything. Now paste it, and we can start training. Now obviously, since you're on your system, you won't get disconnected like in the case of Google Colab, where you might get disconnected every now and then. So obviously you will not lose any progress, but even then this step to restart your training, I have given this over here in case you decide to stop the training process and maybe come back sometime later and restart the training process from where you left off. I have mentioned this step. Now again, this YOLOv4 detector command saves the weights every 100 iterations as YOLOv4 custom_last.weights in the training folder. So if you stop your training, you can come back and start training using this last.weights using this command. Well, this is the same command as the previous one with only one change. Instead of the pre-trained YOLOv4 weights file that we used in the previous command, we are using the last weights file that was saved. Okay, so this will just start the training right where you left off. Okay, so no worries there. Now obviously the speed of this training process will depend upon your GPU. If you have a good GPU, obviously this will train a lot faster. Now let me just stop this, and okay, let's do one thing. Remove this don't show parameter, and what this will do, it will show you the progress chart of loss against the iteration number. So as you can see, you will see the loss, and the progress will be shown every few steps. You see, as the training progresses, you'll see the progress over here, and also you'll see the MAP mentioned here along the loss axis, so you can find out which weights file has the best MAP using this too. So okay, now I'll pause this and come back once we have reached at least 100 iterations. So we have our first saved weights file. Okay, so as you can see, now after each iteration you will see the average loss over here. Obviously this is very high when it starts out, but this will start to decrease, and you can obviously stop it once it goes below 0.2. At least try to get it as low as possible, around 0.05. So okay, after 100 iterations, inside, as you can see inside the training folder, we have this first weights file saved, so we can restart training from over there. Use the same command, just instead of the pre-trained weights file, I'll give the path to this YOLOv4 weights file, and you will see this will start the training process from step 101. This is just in case you stop the training, but obviously since we're on our system, we don't have to do that. I have just given this step so you know how to do that. Okay, let's stop and see where it began the training from. Okay, so as you can see, this started the training process for 101. Okay, so that's how you can restart your training process. Okay, so I'll now pause this and come back later once we have finished all the 6000 iterations, and then we'll carry out the rest of the steps. Okay, so I already had these weights files saved in my computer, so I'll just quickly show you. This is how the final output will look like. This saves the weight every 1000 iterations like this, and then weights file called as best.weights file. This is the final .weights file that is reached after the last iteration, and obviously this is what saves after every 100 iterations. So okay, now we can move on to the next step. that is check performance. Again, you can check the performance using the training chart. You can find out the weights file that has the best MAP using that. This will look like this. As you can see, the MAP over here, and we can find out which weights file has the best MAP and at what iteration, so we can use that weights file for detection, or use this step to find the best MAP. First check it for 4000 iterations. Let's see what the MAP, the accuracy is. Okay, so as you can see, the MAP at 0.50 is 0.99, that is 99%, 99.44. that is really good. Now, so I know this 4000 weights file has really good MAP for me, but let me check it for the best weights file. Okay, so it is almost the same. As you can see over here, 99.43. the best weights file also has almost the same MAP, so we can just use that. Okay, next step, test your custom object detector. First you have to make changes in your custom config file. Set batch to 1 and subdivisions to 1. You can either do it manually or by just running the code below. This will automatically do it for you. Basically what we have to do is go inside this CFG folder, CFG file. You have to make the changes over here. You can either uncomment this and comment these. This is for testing, for training, as we already have mentioned over here, or you can just change this to 1. I'll simply use that command from over there, and that's it. Let's open this. You will see the changes have been made. Now, okay, moving on to the next step, run detector on an image. Upload an image to a folder named mask test images on your desktop. I already have done that. I have this folder over here. I have this test image. Okay, so this is the image that I will be using for test purposes. Now you can simply run this command. Let me quickly go over the usage. Again, this is the Darknet executable file. Detector test is the command. obj.data file, your CFG file, your weights file that you want to use. I'll use the best weights file as I mentioned earlier. And finally, this is the path to the image that you want to test. This is the threshold parameter. You can set this to whatever you want. This sets the minimum accuracy required for object detection. So right now it is at 30%. You can change this to whatever you want. Just copy this. Now this will save the output as predictions.jpg inside the Darknet folder. Over here, as you can see, it has detected. You can see it over here as well. Now what I want you to do next is just run this command to copy the predictions.jpg file from the Darknet directory to the mask test images folder over here. This will save it as output underscore image 1. Okay, we have this file over here. So now we will see. Okay, so as you can see over here, this has detected the mask with 99% accuracy. You can close this. So that is how you run detection on an image. Okay, so now next we'll run detector on a video. Again, do the same. Upload a video to a folder named mask test videos on your desktop and run this command. let me quickly go over this command usage. Again, executable detector demo. Demo is used for videos, your obj.data file, CFG file, your weights file, the input video that you want to test the detector on, the threshold, that is the minimum accuracy required for detection. Right now this is at 50%. And finally the output file name and the output directory. This will save the video as output.avi inside the mask test videos folder itself. So I have this videos folder over here on the desktop. This is the video I'll be running the detector on. So okay, this has both the classes, without mask and with mask. Let's run the detector on this mask. Okay, let's run the detector. Okay, so now let's look at the output video. Okay, this is working perfectly, as you can see. For a close-up video, this is giving a pretty good output. Okay, so let's move on to the next step. You can also run this on any video containing both the classes together, as in this video. Okay, again, next step, run detector on live webcam. Just run this. The command is the same as previous one, with the only difference being I have removed an input video and the output directory from this. So this will run detection on your webcam. So as you can see, the detection for this is also pretty good. This is detecting my mask right now with almost 80% accuracy. So obviously this will depend upon your GPU. Okay, moving on. Okay, so that was it for this tutorial for YOLOv4. You'll find all the links below. Now moving on to the YOLOv4-tiny tutorial. Now, as I mentioned at the start of this video, this is the same as YOLOv4 with a very few changes. I'll just quickly show you the changes that you need to make over here. Okay, so for YOLOv4-tiny, again, all these steps are the same. I've made the necessary changes to the folder name in each of these commands, so you don't have to worry about that. Just instead of the YOLOv4 folder, we will be uploading everything in this folder, YOLOv4-tiny. This is just so you can easily differentiate between the two, so you don't have any errors in the future. So okay, everything's the same. Just the first difference is this, the custom CFG file. For YOLOv4-tiny, we have a separate file over here, that is this YOLOv4-tiny. In this we have only 2 YOLO layers as compared to YOLOv4's 3. Over here you'll find only 2 YOLO layers, so you have to make these changes only twice. This is the second layer. That's it. You have only 2 YOLO layers over here, and these are the changes. Maximum batches, the steps, just like for YOLOv4. So obviously you'll also find these files in this repository over here. I uploaded this for YOLOv4-tiny as well. Okay, so this is the GitHub for my custom YOLOv4-tiny files. You'll find all these files over here with the custom CFG file for YOLOv4-tiny as well. The above 3 files are the same as we used for YOLOv4, but it's okay if you download all these files from here. Okay, so again, just let me show you one thing. You can also find the CFG file over here when you create this Darknet folder or download it from the official LXCAB website. You will find this YOLOv4-tiny CFG file here as well. So there are various other files that we will be using in the future for other purposes and other tutorials. Right now this is the file that we need. You can copy it from here as well, that's okay, or download it from my GitHub repository. Okay, as I mentioned earlier, the only difference in the CFG file is that this has only 2 YOLO layers and the 2 convolutional layers above each of the YOLO layers, so you'll have to make these changes only twice. Okay, these steps are the same. The next difference is that we download this YOLOv4-tiny pre-trained weights file, which has been trained up to 29 convolutional layers, the YOLOv4-tiny.conv.29, and we will be using that in the next command over here, as you can see. Okay, and rest all the parameters are the same. Now the training process and the detection for this will be a lot faster, as this will be only around 22 megabytes. Let me show you the weights. This is a lot smaller than the YOLOv4 weight files, which will be huge, 256 MB. So obviously YOLOv4-tiny is a lot quicker and also preferable in case of real-time world scenarios. So for live webcam or anything like that, you can use YOLOv4-tiny. Now again, all the next commands are the same. Okay, so that was it. These were the only differences in both these two tutorials, nothing major. If you have any doubts, you can just refer to these articles. That will hopefully clear all your doubts. So okay, that's it for this video on how to train a custom object detector using YOLOv4 and YOLOv4-tiny on Linux for your local machine. So okay, I hope you enjoyed this video. So please click on the like button if you enjoyed this video, and make sure to subscribe to this channel. And okay, I'll see you in the next one.